Hi all, welcome to our project video under the topic of Agriculture Monitoring System, IoT based. We are inheriting IoT in our present agriculture to increase our agricultural productivity and to reduce manual intervention in the fields. Also it will be help them to sustain in our near future world as we are using cloud-based systems which can be accessed from any part of the world. Will enhance farmers with accurate data and act accordingly. COVID, a contagious disease which is shaking the whole world with its unbelievable effects. COVID did not leave agricultural works too. It made adverse effects as humans scared to work with other people thinking that it may leave them in danger. Before COVID we had numerous workers who were helping in development of agriculture and we had a great yield. After COVID we are not getting people to work on fields and now they are getting dried and are converted to residential areas. So if this increases we will strive for food in future. So we came up with a solution which can sustain in future and gets it updated. Our solution is to introduce IoT and electronics in the combined manner which will increase yield and reduce manual intervention. IoT is not just for IT sector, it can be used in well-versed manner in agricultural works by integrating with fields and access them from any part of the world. Methodology. Hardware parts. Raspberry Pi 3B+. The Raspberry Pi 3 Model B+ boasting a 64-bit quad-core processor running at 1.4 GHz, dual-band wireless RAN, Bluetooth, faster Ethernet. Soil moisture sensor. The soil moisture sensor is used to measure the volumetric water content of soil and is reported in percent. HT11 sensor. HT11 a temperature and humidity sensor which has a dedicated NTC to measure temperature and humidity as serial data. PIR sensor. PIR sensors allow you to sense motion, almost always used to detect whether a human has moved in or out of the sensor's range. GSM module, SIM 900 can use this shield to accomplish anything a normal cell phone can. SMS text messages, connecting to internet through GPRS mode. Softwares. Cloud technology. Cloud computing technology allows people to use the digital resources stored in the virtual space by way of networks. Mobile application. A mobile application, also called a mobile app, is a type of application designed to run on a mobile device, which can be a smartphone or tablet computer. Our model setup. Our model setup consists of soil moisture sensor which is used to detect moisture content from soil from the agriculture fields, and the same analog data is sent for processing in Raspberry Pi. Next part of our setup is HT11 sensor which is used to detect temperature and humidity from fields and same has been sent for processing. Next we get into PIR sensor. This sensor is used to detect the animal or manual intervention into fields where these are placed in the outer sides of fields or in the fencing. This will be useful in night where we can prevent unwanted intervention. These three sensors are connected to the processor which is Raspberry Pi 3B+, where we have coded here to convert the analog data to the digital readable data which is received from sensors. Then these digital data is sent to GSM module. GSM module, where it has a SIM to activate GPRS internet facility so the received data from the processor can be sent to the cloud by hitting the API URL. Cloud. This is used to store our data from the GSM module where these data can be accessed from any part of the world and it can have multiple setups connected. Next we are into our main part, mobile application. This is fully designed by us for the requirement to show the data from fields and notify user whenever needed. This application will be enhanced in future. Our mobile application. This is our application where user has to enter name, mobile number fields and click login button. In second page we display the username and phone number for confirmation and it has button for get data. When it is clicked we get navigated to next page, where we display the data from the field and it has a refresh button for refresh the data. We have stored those data in cloud so it can be accessed later. Features. IoT. IoT means interrelated computing system. It is embedded with sensors and software and other application. By implementing this, we can get the data from any part of the world at our hand at any time. Smart system. Smart system is a combination of both human and machine. It integrates the sensing device to operate and make a decision based on the availability of average data in an adaptive manner. Real-time data. By implementing the cloud and application, we are able to get the real-time data at any place from the world. Animal intervention. We have implemented a PIR sensor which can detect the animal or human intervention and notify during night time. Accurate value. By using the sensors, we are able to get the accurate value. Low cost. We are not compromised in the quality of data we are providing in spite of low-cost sensors. Automation. As our app has the feature to notify users about dryness of fields and interventions which can reduce human work. Greenhouse. Our project is most useful to the greenhouse system because this will help the farmer to view the data of the greenhouse from any part of world and act accordingly. Future developments. In future, we would also detect the level of nitrogen, phosphorus and potassium level in our field by affixing the NPK sensor. Similarly, by affixing the light sensor, we could detect the intensity of light, that is the presence or non-presence of light and darkness in the field. Air is important for each and every living. The attachment of air quality sensor would measure the level of gas content present in the air. By correlating our application with Agriculture University of Tamil Nadu, they would share their data with us. These data will be stored and we could analyze the change of temperature, humidity, and moisture for each type of field. Now, the Indian government has implemented schemes for farmers for irrigation. We are planning to include the system so a farmer need not go to a field for irrigation. We will automatically irrigate plants as per data stored and with some criteria. We could also have correlation with meteorological departments and detect the level of rainfall, chance for rainfall and prevent loss of crops due to overwatering. Summary. Development of technology not only destroys agriculture by occupying the lands, it also develops it. Intelligent use of agriculture and technology will revolutionize our lives and frame our response to future world. Our project will help agriculture and farmers to sustain in near future with technologies, with increased yield and reduced manual work.